better introduce myself. I'm Gareth Ellis. I'm the Energy and Environment Manager here at Cranfield. John mentioned the carbon management plan being put in place in 2009. That's when I was recruited as Energy Manager. So I followed that carbon management plan through to where we are today. So as John said, our target was this 50% reduction. And that was despite the fact that it was projected the university would grow and probably almost double in its turnover in the sort of time period we're looking at. Having said that, we have really been very successful in making some early gains with this. And since 2010, we're into the sort of 22, 23% at the end of last year, and we're projected to actually make the 30% saving at the end of this year, not least because of this biomass boiler giving us an extra boost this year. And if we carry on with this progression, we will hit our 50% target. But there's still a lot of work to do, obviously. I think one of the key reasons we've managed to achieve this is because we invested in the combined heat and power unit, again, back in 2010-11. We've made lots of investments in energy efficiency and energy awareness campaigns. They've clearly made their mark. But a key factor for us has been fuel switching. So the combined heat and power unit means that instead of importing lots and lots of electricity, we're actually importing gas, which has a lower carbon value. And the CHP unit is using that gas to generate about 50% of our own electricity, and that makes quite a big impact. And these graphs are trying to illustrate that. So if you look at the left-hand graph, that is where we were back in our baseline year of 2005. So it's looking at it in CO2 terms. The blue is the electricity that we were importing. So it was our biggest source of carbon emissions. The red is gas, and the green is oil. So two things. You'll notice that we weren't importing that much gas compared with oil. And oil was a significant part of how we were heating some of our buildings. Then if you look at 2011-12 on the right-hand side there, after we'd installed the CHP, you'll notice two things. One, we'd pretty much got rid of oil, and that's partly a sort of push to convert buildings that were on oil onto gas or onto our district heating scheme, or actually just moving out of those buildings altogether. So we have been rationalizing parts of the campus. The other thing you'll notice is the electricity went down considerably, and as I said, the CHP unit is the reason for that. So we've actually switched from being our CO2 emissions largely coming from electricity to perhaps pushing towards the fact that gas is responsible for most of our CO2, albeit that the overall CO2 has gone down, which is what we're looking for. But that's also prompted us to start thinking, well, we don't want all our eggs in one basket. We don't want to be here in 10 years' time completely reliant on gas, albeit it seemed to be that we've kind of picked a winner at the moment because gas hasn't gone up in cost in the way that electricity or oil have. So we did start thinking about, well, we really need to look at, not just from the carbon point of view, but also where are things going in the future, and do we really want all our eggs in one basket? Just a quick overview of our district heating, because having invested in that combined heat and power unit, we need to make sure we're going to get the maximum out of it. And by getting the maximum out of it, we need to make use of the heat that the generator creates. So back in 2010, we had two networks. The black dotted line was a steam district heating scheme, and the green line was a low temperature hot water district heating scheme, feeding some of the smaller buildings. The steam was being used to heat the larger hangars, and this was kind of rationale behind that. High temperature source, very good for heating big spaces. Very difficult to maintain, and the pipework was basically corroding faster than we could repair it. So we got rid of the steam to the two hangars at the south of the campus, which had already been converted anyway into offices and lecture rooms, etc. And we added those onto the LTHW network. This is the point at which we started planning for the biomass boiler, and as John Street said, we looked at a different location for that, for the future boiler house. And also our plans are to get rid of steam altogether. We see no longer that we actually need the steam, and it is something which is difficult and costly to maintain. The other thing I suppose to point out is that at the moment the district heating is just serving our technical site. It's not serving our residential quarter, which obviously has a big heat demand, and we have got some future plans for that. Okay, at this point I'll hand over to Steve, who'll talk to you a bit more about the how we went about this.
Hi, Steve Shotter. I project manage the overall project for the district heating. Gareth and I have been talking about biomass since 2009. We looked at various locations, Mitchell Hall, which is a residential site. That was discounted because of noise of delivery, difficulty of delivery. We looked at the test site, which is at the other end of the campus on the south. Great position for the boiler, but deliveries were really good, but interconnectivity to the site, absolutely appalling. And then we looked alongside the main boiler house, but as John said, we're going to relocate the boiler house from there. 2013, Gareth got a loan from Hefke. There were some key points on the loan that we had to have a project that was involved with the teaching on the campus. We have a large energy department within our schools on the campus, so we tick that box. It has to be open and accessible for students and the wider university community. You guys are here today, so we've ticked that box. We've also made the buildings accessible for people to walk around and see. And the money had to be spent on plant and equipment, not necessarily brand spanking new buildings. So the only new building we've got is basically, dare I say, a tin shed, which was of low cost. The university also put some funding in place for us. So it was a sort of 2/3 and 1/3 funding from Hefke and the university. But it's not just about a boiler. We're not just saying, okay, here's a room, stick a boiler in it. We had to upgrade some of the further district heating. So building 62 to 63, we increased pipe work from 6-inch to 8-inch diameter to move more heat down the site. We had to upgrade our heat metering. I think this is an area that we haven't really succeeded. The heat metering we still haven't quite got on top of, but we're working on it. We had to make the boiler house, or the room that became the boiler house, into a boiler room. It was previously a store. It had chairs, rubbish. It was a dumping ground. So we had to convert that to make it into a boiler room. Then we came along with the boiler, the fuel store, which we'll go into detail in a moment. Then there was the delivery issue. We have large articulated lorries coming in delivering fuel. We needed to make sure that they could get in easily, so I had a road to upgrade. And then there was the fuel supply itself. Where do we get the fuel from? What type of fuel? With the decision for building 3, we made a lot of box ticking again. It was away from the centre of the campus, so it's not in the heart of the business area, certainly the school and management land. We could easily connect to the main boiler house and the district heating pipework network, so we could get the heat out of the boiler house and into the site. The existing building, as I said earlier, was a store. It was underutilised. It was a dumping ground. It's a much better boiler house. The fuel store is on, as you will see later, is on the back of the site. It's a good location. It's tucked out the way. It's on the main road to the airport, so it's still quite an attractive building. And access for delivery is very good in that position we've chosen. We developed the scheme, Gareth and I. We brought in Sam Engineer from Engineer Associates, Dave Baldwin from RecoGen to assist us. We developed the project with various manufacturers, including Clear Power Flow Gas. Boiler manufacturers were very helpful to us. And we developed the scheme pretty much an in-house process. We did the basic design. We created the tender between us all, and we launched the tender as a Cranfield University managed project. We looked at a couple of options. The first one, I think our eyes were too big for our tummy. We went for a walking floor scheme with a submerged boiler house. The contractors put a lot of risk into that, and the price was quite high. So I think we did quite a radical thing. We sat back and we didn't sort of try the same scheme again. We looked at an alternative. We decided on the top loader process and realised then the benefits of it. It's lower capital cost, lower construction and machinery cost. We can get to every moving part without having to empty the fuel store. And the delivery process is really easy. The lorry just backs in, as you will see later. As I said earlier, we had a very tight, concise user's requirements specification. We gave specific idea of what we wanted in the way of layout, but the final design was down to the contractor. We went out through OJU because of trying to spread the net of where we can find qualified contractors to bid for the work. We also went through the Intend electronic tendering system. We had about 26 expressions of interest. We had an open day where we took contractors in 2 groups around the site. Every contractor got the same information, so nobody was given a full steer. We actually only got 6 serious bids. Clear Power's flow gas, theirs was the most compliant bid. Part of the evaluation was compliance to energy efficiency, to the quality of the equipment, to the RHI accreditation. Flow gas ticked all of the boxes and they were the lowest cost, so that made life easy. We would have considered a higher cost had the compliances been better, but Flow Gas ticked all the boxes. They were appointed on a turnkey design and build basis. They supplied all the equipment. They designed the fuel store. They designed the foundations. They designed the foundations for the boilers. So they took the job from the beginning to the end. And with Sam Engineer, they developed a control process and how we're actually going to make this talk to our district heating scheme. Just going to recap quickly. So we created a boiler room. We had a crappy old store, excuse the term, a rubbishy old store, which we had to completely gut and refurbish, and we turned it into a nice clean space for a boiler. We had a greenfield site at the back, which wasn't actually that green. It was full of cables, it was full of old pipes, it was full of rubbish from previous life. We had to take down a couple of trees, which was unfortunate. Fortunately, they were not the best specimens on the campus, and we have made mitigation elsewhere on the campus. We built the fuel store on that space. Then the boiler came. I quite like the left-hand picture where they lifted the lid off the lorry. Then they craned the boiler into position. Again, all managed by Clear Power Flow Gas. The boiler was a bit of a tight fit to get in, bit taller than I think we all imagined. Although we got the tape measure out and we knew it would fit, on the day it was a bit of a squeeze. And then it was installed into its current resting place. The chimney arrived, another spectacular day because again you could see something was actually happening. So the guys delivered the chimney in 2 parts, lifted it over the building. Then I had my road to build. As you can see on the left-hand photograph, it was just a scrubby car parky piece. That is actually the hammerhead at the top where the lorry drives into to reverse back, and the right-hand image is the nice finished tarmac section. So it makes a nice easy sweep in for the lorry and reverse back. And then the top loader building, as I say, we made a decision to go with a top loader. I was surprised at how gentle this machine is. When you watch it working, I'd always imagined in my mind's eye that it just grabbed big lumps of fuel and pulled it back into the boiler. It doesn't actually, just gently sweeps it in. Hopefully you'll see it in action later. Depends on how hungry the boiler is. On the testing and commissioning, Sam Engineer set up a really tight testing regime along with Dave Baldwin. And I think we really did put Clear Power Flow Gas through their paces on that one. And they passed the tests. It was an interesting exercise, which I'm sure Sam will talk about later. What did strike me at the firing stages, being used to gas-fired plant where you switch it on and away it goes, was actually how long it took to get the boiler into operation first fire. The firebox was very damp, so that had to dry out very slowly, and that did create some issues with smoke on the campus. But once it was up and running, it was absolutely fine. Installation issues, we had quite a rigorous planning application. We had to fill out the Central Beds Council biomass installation application form. Again, clear power flow gas helped us with that. I think Central Beds are very much up to speed with energy environmental projects. We're not the first biomass boiler in the area, so that was quite not such a big hurdle to jump over. Other problems was the buried services, as I said earlier. We had all sorts of cables and pipes. We have a very high water table, so every time they dug a hole, it filled with water. The interface with the district heating pipe wasn't a difficult task, but it wasn't just find a pair of pipes and connect to it. We had to really plan out how we did this. And access and traffic management over the site with pipes going between building 3 and the main boiler house was an issue. The achievements, I believe, is that the efficiencies and output exceed our expectations. We always thought we'd get a good job, but I think in its operation for the last year or so, it's been proven. We've ticked every box in the loan funding requirements. We have a scheme that we are proud to show others. I said this on the first day when the contractors came round, that I wanted to be able to do this sort of presentation to people like yourselves and say we are really pleased with what we've got. Students, the Vice-Chancellor and the senior board members have been around and looked at it. The senior council board members made comments that are surprisingly interesting. I don't know what they expected to see, and I don't think they particularly wanted to come, but they walked away with a smile on their face thinking, well, this isn't actually that bad. And of course, you guys are here today, so that's a major achievement for us. Thank you.